Welcome to an introduction to Fade. Fade is an ESP32-based animation and control system. And as for why I built this system, well, I like to build holiday ornaments, and my holiday ornaments are animated. And I have a lot of different ones I've built over the years, and some have been easy to build, but most have been kind of hard to build. And I wanted a system that would let me build these things much more easily. So what were the pain points I cared about? Well, the first pain point was the slow build, deploy, and test cycle. And this was slow because just kind of the realities of writing code on one system and having it execute on another system. So you write the code, you build the code, then it needs to be shipped over to your microcontroller, and then your microcontroller starts running that code, and then you look and try to figure out whether it's doing what you want or not what you want, and then you go back to your system and change your code, and you just keep going through this build, deploy, and test cycle. And that tends to be kind of slow. Now, if you're building the kinds of systems that I build, it's quite a bit worse because that microcontroller lives out someplace in some sort of system in my yard. And that means I'm going out and pulling the board out of the system and bringing it back into the office to do the update, and then taking it back out and testing it. And that just makes it much, much more tedious. A third problem I have is that I've been writing the same code over and over for the whole time I've been building these things. And the systems I'm creating have gotten a little bit more sophisticated, but generally it means that I have to do something new, and I have to go back and familiarize myself with old code, and it's just a lot of hassle to have that. And then the final pain point I have is sometimes I'll have a good idea, or what I think is a good idea, and I'd actually kind of like to prototype it. But I can only prototype it on running hardware, so I have to get one of my microcontrollers out and then get some of the LEDs I use out, and maybe they're not arranged the way I want, so it can be a lot of work up front just to test an idea out. So, the Fade animation system is really a very simple system. The system operates with a 12 millisecond clock. So what that means is updates in the system happen 100 times a second. The system knows the current color of every pixel. So it knows pixel 0 is a color, pixel 20 is a color, all of that. And in the system, we write code to define the target color of each pixel at a certain time in the future. So, for example, we might say set pixel 0 to color blue in 4 clock cycles. And let's just assume that pixel 0 is currently green. What will happen? Well, we'll have 1 clock cycle, 2 clock cycles, 3 clock cycles, and 4 clock cycles. So all we had to do is just say, hey, whatever the color's there, change it to blue. This is how long it should take, and the system went off and handled that. So that's the basic system. Now, rather than just showing you lots of PowerPoint or talk about it a lot, I'm going to do most of this video with demos. So to help me out with that, I have 3 little helpers here. So to start, we have a red globe that has 33 LEDs. We have a green strip. I don't know how many that has, probably 30. And then we have a blue snowflake, and it has 55 LEDs. Now these are all RGB addressable LEDs, so those colors are just the colors they happen to be now. But those are the physical devices that I'll be using for my demos. So, time for the first demo. And in the inset window, you can see the LED flashing. So it's just flashing off and on. And in the background, in the big window here, can actually see the source code. Well, actually, this is the source code for the animation system. It's not the source code that we're running to do the LED. And for that, I'm just going to switch to a different window. So here we can see a little web page. And this web page is created by the ESP32 running the Fade controller software. And the actual code we're running is just these 3 lines of code here. So the first one, to start, you need to tell the system what it has connected to it. So the first chunk of LEDs, so it's chunk 0, is RGB, which means WS2812. There are 15 LEDs in the string, and it is currently connected to pin 15 on the microcontroller. So that's the setup. And then we're doing a direct or a dim immediate command. We're going to do it over 25 clocks. It is LED number 5. So if we go over here, we can count 0, 1, 2, 3, 4, 5. So we can see it's the 6th LED, LED number 5. And then this is the color that we're going to. So that's RGB, 111, or white, all of them turned on. So what does this say? Well, over 25 clock cycles, change LED number 5 to color 111, or white. So that's the dimming from black to white. And then the next operation, well, it's just the inverse. Same LED, same clock cycles, and dim down to 000 or black. And so this whole thing here is just kind of a little IDE, a very, very simple IDE you can use. And if we wanted to change, let's go from white to red. And now I'll hit send. And that's going to send it across. And you notice it changed to red. What actually happened was the microcontroller took the new program, saved it away, rebooted, reconnected to the network, and then started running that program. So as you can see, the turnaround cycle here is considerably quicker than it would be if I actually had to build code and download it. So that's the end of the first demo. And here we are for the second demo. So we're starting with our little flashing red light. And I could go in here and write a bunch more code. And that's what I did in projects for a while, probably for a year or so. And then I realized there was probably an easier way of doing things. So I wrote this little application, and this little application is called WinFade. And let's see what we can do with WinFade. Now you notice down here, it's connected to Fade Demo. That's the instance that we were already talking to. It has the same IP address. And what I can do is I can create a new kind of instance from the remote. So that went out and talked with ESP32 and pulled the code off of there that was specifically running already. And the neat part about WinFade is it hosts the exact same animation system that is running on the ESP32. It's the identical code. So I can pull some code over, I can click run, and there we have, running in a little output window, a simulation, but a pretty good simulation of what's happening on the actual device. So what that means is I can write code over here, and it's just a little nicer. This will let me save things and go forward, and I can do a bunch of things. So what do we want to do? Well, let's just do something fun. And there's a specific language that this code is written in. The language is also called Fade. Let's just make a bunch of LEDs do this same thing. So we'll say for LED 0 to 10. So that's 0, starting at 0, ending in 10. this is a line language, line-based language. Doesn't have semicolons. So let's add in LED. So we can see we're doing the same thing. Now let me reformat. So it actually looks like real code. So what do we have? We're going to go through 10 LEDs and we're going to flash them one at a time. So run that in our little simulator. I'm going to have to change the size a little bit here. And we can see it does pretty much what we would expect. So let's try the real test. Ship that over. And we notice, what did we do? We changed it on the code here. And then we can ship it out to the actual instance running on the ESP. And this has a lot of advantages. It's obviously a lot quicker to write stuff here and then click run. It's a little easier to detect errors. So it ran through the code and it found that there's a missing int4 and it even highlighted it for us. So the ESP would detect that there was an error and it'd tell us, but it wouldn't be quite as nice about it. And that's the first intro to WinFade, and we'll start adding to that in future intros. Time for the next demo. So let's start with the code we had before. So that's code currently running on the device. As you can see, if we run it here, you can see it's just incrementing across. And all we've done so far is done operations that only occur on one LED at a time. So dim this one, dim the next one, dim the next one, dim the next one. And that's really not that much fun. So we're going to switch over and try to write something that is more interesting. So what I'm going to do, I'll show you the first thing. And we'll add a variable called LED current, set that to 1. I'm going to get rid of this for loop. I think we're going to use a while loop. And this will be a endless loop, which doesn't really matter because we're actually trying to keep animating until we're done. So what we're going to do, I'm going to reorder these, and you'll see why in a minute. So we're going to say dim whichever one is LED current down to 0. And then we're going to say LED current plus plus. So that'll go to the next LED and we'll dim the next one up. And right now that looks like it's going to be exactly the same, pretty much the same as what we're doing before. But if we hover here, we should see define, DI means define and execute a fade. And we're going to use a different primitive. I'm going to use D, and D is just defining the fade. And since we do that, we'll have to add a separate execute. So what does this mean? Well, now it means over 25 cycles, do this dim. Over 25 cycles, do the next dim. And that's defining 2 dims or 2 fades. And then the A will cause them to execute at the same time. So what we should see is one LED dimming and the next LED brightening at the same time. So it should kind of work down the strip. Now, we have a problem when we get to the end. So I'm going to say if LED current is 15, LED current equals 0. This won't be the final version. I can go and reformat, but I think this should run. So let's give that a try. And what you notice how one of them is getting bright and the other one is fading. Now, if we want to make this a little cooler, we can actually change the timing on these. We should say that the brightening, let's say it happens in, the dimming, let's say that happens over half a second. And the brightening happens over, let's say, that'll be a tenth of a second. So notice how we get kind of a longer trail. Now there's one brightening and then two fading. And let's push that a little farther. I think this will give the effect I want. Okay, and you can really see the effect we're looking for there. So this is very nice. It's a little weird to think about because what's happening is, because of the way the loop's structured, we set this dim to happen over 50 clock cycles, but we're only animating here 5 clock cycles at a time. So we set up this one to dim over 50, this one to get bright over 5, and we only animate 5. So this one you can think of dims the first chunk. It does the first 5 of that 50. So obviously that doesn't dim it all the way. So that's how we get that trail there. Now, because it's a requirement, I'm going to have to add some new structure here. And you'll see why in a second. So you can see Fade supports the usual kind of C-style operators, pretty much what you would expect. So I can get rid of these lines, and then I'm going to add something else here. And it's going to say, we'll see if I get this right, if LED current equals 0 or LED current equals 15. Then what do I want to do? I want to say increment equals minus increment. So, is it going to do what I want? No, it didn't do what I want. LED current. Really? Okay, well that's embarrassing. What did I forget? I have the while. Let me look at my cheat. It's possible that's broken. Ah, something is broken with plus equals. Okay, I just wrote myself a little note. And here we have the very popular Larson scanner. And this was, as you notice, it was actually pretty quick to implement. You know, what do we have here? We have, I don't know, maybe 10 or 12 lines of code here. So really not that much less than I would have had to write if I was doing this normally in C++. So let's see how lucky we are. Finish that. Let's send it off to the remote. And there we go. Same code running on the remote. So you can see why I like to develop inside WinFade. It's just a whole lot quicker to do this sort of thing. Now I think watching that in the real world, we're gonna make the fade a little faster. Let's try updating again. There, I think that looks a little better. So you can see, really easy to play around with and really easy to make the changes. So the big key part of this is to introduce these overlapped operations. You can have multiple operations going on different pixels, and they just keep animating until that cycle count has finished. So that's all for this demo. Here we are showing the previous effect, the red chaser. And I like red a lot, but I think it'd be nice to have a different color. So let's go and do that. I'm going to use this to introduce a few different things. And I'm going to start by going up here and writing a function. So there's func, infunc, and I'm going to call that, we're just going to call it getColor. It doesn't take any parameters. I'm going to start by writing this just to make sure that it works the same way. So what I'm going to have it do is return 1, 0, 0. And the interesting thing about variables in Fade is you can essentially think of every variable as being an array. So this variable has 3 components. It could have 1 component, or it could have 10 components. Just kind of whatever you want to do. Obviously 3 here, we're going to interpret it as red, green, blue, but it could be interpreted some other way. And let's just introduce a variable. So we're going to have color, call getColor, and then down here, instead of this hard-coded, we're going to use color. Does that make sense? Call the function, have it return something, and then we'll use it in the loop. So, and there we go, does the same thing. So that's what we expected. So now let's change this function to do something different. And what I'm going to do, red equals rand, green equals rand, and blue equals rand. And you can probably guess that rand returns a random number. In this case, it's a random number between 0 and 1. There's another way you can call it. You pass parameters, and it'll give you a minimum and maximum. So 2 different options there. And then instead of returning that, we'll return red, green, blue. And reformat. Let's run. Okay. And we notice it returned sort of a green, which is fine. Now, nice part, let's actually change the color every time we increment. So color equals getColor. And run. And now every time it bounces, it switches to a new color. And that really looks pretty good. The one thing you'll notice, every once in a while, we end up with pretty dark colors. And that's really not surprising. You know, sometimes red, green, and blue will all be pretty low. And that means we get colors that are kind of dim. I would like to have colors that are brighter. So we're going to make one final change here. What I'm going to do is, see if this code makes sense. I'm going to use another function called max. So that's going to return the maximum of the red and green and blue. And what I want to do is take that to whatever value, from whatever value it is now, and change it so that it's 1.0. And then change the others proportionally. Now, because of the way our eyes work and brightness works, it's not going to be perfect, but it'll probably give me the effect I want. So now I can figure that out, and then I can figure out what factor I want. And this is 1 divided by max, I think. So let's think of an example. Let's say red is the brightest, and it's at 0.5. So max is 0.5. 1 divided by 0.5 will be 2, so the factor will be 2. So now I should be able to just do times factor. For each of these. And let's see. Okay, so I get pretty much the same effect, but you'll notice the colors are all bright colors. I don't get any more of the dim colors. So let's try sending that across and see what we get. Okay. As usual, when trying to videotape, the colors kind of wash out. But you can see we're changing colors every time. So that showed how to do functions, showed how to use random numbers, max, and just to do some more fun stuff. So that's all for this demo. Time for another demo. We're going to start with the chaser in different colors. And that's fine if you're actually dealing with pure strips and they're all always aligned the way you want. But sometimes you might want to have something where you have different sections of strips. So the LED setup dialog lets you change essentially what WinFade thinks the physical layout is. So you can see right now there's one group, it's group 0. If you remember, we're looking back at our code. We defined 0, the group 0. We'll get into multiple groups later on. So group 0, the LED count, it's 15, the size is 30, the spacing is 40. All of these control how the strip looks. So what we're going to do is we're going to add a few more strips. Now the first one is going to be 5. Second one is going to be 5. And the third one is going to be 5. So basically what I've done is I've said that I have 15 LEDs, but break them into 3 physical segments, each of them 5 long. So now when we go to run, okay, that looks all messed up, doesn't it? That's because we have segments overlaid. So what I can do is I can start dragging them out. I'm going to try to figure out what order. Okay, so this is the right one. And then this is the left one. So this allows us, if we are trying to do something, maybe we're trying to make a big 7-segment display or do something else, this allows us to do that. And I've noticed we actually have something a little weird there. The spacing is different. So spacing 40, spacing 50, spacing 50. So let's hope this works. Sometimes this code is a little funky. There we go. So we can move them around. Also, if we want to, it's going to be hard to do because they're only on part-time. But we can drag with the right mouse button and rotate. So let's say I wanted to make a figure like this. Okay, it's not perfect, but that's one of the other things I can do with strips. So I can build figures and write the code on the presumption that my physical LED layout will look like this. So that's all for this demo. Here's another demo. So we already showed how to break the strip into separate strips. But what if we want something that actually doesn't look like a strip? So what if we had a ring of addressable LEDs? So we can go down here, say we have a ring. Choose OK. And there's the same code running in our ring. And like the others, we can move it around if we want to. We can rotate it. It's a little weird, but we can rotate it. And there's an option, if it matters, to change the ordering. In this case, it clearly doesn't matter. So that's ring. Try one more. Matrix. So this is going to be a pretty small matrix. It's a 3x5 matrix, and the spacing is going to be 30. So they should touch each other if this works. Okay, there we see a little matrix of 3x15. So gives us all sorts of fun options that makes it easy to set up the kind of physical LED layout that we're going to want to use. Here we are, starting with our usual bounce back and forth code. And I had a scenario a while back where I wanted code that wasn't an animation that wasn't static. I wanted it to be able to interact with the user. So I added the ability to take user input. And one of the neat things about the ESP32 is it has a subsystem that can use touch input. So essentially you just have a touch terminal and you touch it and the microcontroller says, hey, somebody's touching it, and you can detect that and do whatever you want in your code. So the way we do that, config button 0, make it a touch button, connect it to pin 32, which is what I have connected in the demo. And then this last parameter is a threshold. And that essentially determines where the threshold is of identifying a touch or not identifying a touch. And that depends upon essentially how much metal you have connected and what you're touching and all that sort of thing. There's a debug setting that'll let you print that out so you can choose an appropriate threshold. So now I have a touch button defined, and now we can go down here and change our code. So what I want to do, I want to read that button value. If it's equal to 1, that was not it. I want to take this color change and just move it down there. So that's code change, pretty simple. As usual. Okay, notice now we go back and forth, no change. And if I hit the 0 key on my keyboard, that's simulating the button press. So that's what I'd expect. Now let's flip over. There we have running live. And let's send this across. Okay, you notice it's now staying the same color. Now I'm going to have to walk across the room and touch the button. So you notice every time I touch the button, it changes color. So by doing that, that allows me to change how the animation works, add in user interaction. It supports 10 touch buttons, which is how many the ASP has. It also supports normal buttons, so physical push buttons as well. Now another thing it supports is we can actually trigger those remotely. So you notice down here I have a set of buttons. So remember we're using button 0. And I click on that, and you notice the real hardware actually changes. So kind of hard to tell. Let me see if I can find a color that looks very much different. There, you can see that was a good change. That's a good change. So basically, as part of the same code that handles program updates coming over the web interface, we can walk up to the web interface and say, hey, you pressed button 0. So this gives you remote control not only with physical buttons, but with virtual buttons. You could do it from your phone or from any browser. So that is how button support works. Here's another demo based on one of my existing projects. The existing project doesn't actually use this animation system, but I built the system so it could. And this is a pretty simple thing. So what I have a string of 55 addressable LEDs, and while they aren't actually in a string, let's flip over. They are actually in a snowflake. So that means a whole bunch of different LEDs in different locations. And to do that in the code, I have these really big arrays. And this array is basically the angle of each of the LEDs. And then this array is the distance. I don't actually use a distance in this animation, but I have both of them. And then what do I do? Well, pretty simply, I increment angle from 0 to 350 in steps of 10. So you can think of that as rotating through 360 degrees. And then I take the angle, the current angle, and add in whatever the angle is of the specific LED. So that essentially lets me rotate each LED, but at whatever offset angle they have. And then there's a built-in function. HSV is a different color space. So there's RGB, red, green, blue, and HSV is hue, saturation, and value. And the nice part about HSV is you can just increment through the hues, which run from 0 to, I guess, 359. And that will go through all of the colors. So there's a built-in method or a built-in function to do that. Now, once again, I didn't want to actually have the hardware to be able to test that. So if we flip here, we see this is set to custom. And there's a essentially special paste format you can use to set up your custom LED arrangement. And then we see, I can choose run, and there we have the same operation running in WinFade as we have running on the actual hardware. A little easier to see in WinFade. Unfortunately, the camcorder just gets absolutely blown out with the amount of light that the LEDs are putting out. So this is the fallback for I can't make what I want out of strips or rings or matrices. I really just need custom positioning. So this lets you do that.